6.1, Day 2. The other common measure that we'll take a look at in trigonometry is called radian measure. A radian is the measure of a central angle that intercepts an arc on a circle. If you look at the picture on the right, a radian is going to represent distance. And you're looking at the distance on the circle covered by the measure of the angle on the inside. So notice you have that little zero with like a slash through it. That zero with that slash through it just means theta, and that is your angle measure. So theta or angle. Notice the vertex is at the center of the circle, making it a central angle. Now what that angle does is it has an initial ray and a terminal ray, like we talked about in day 1. The angle in degrees is the part on the inside. That would be your degree measure. But now if we look at the portion of the circle that it intersects, that length is called your radian length, or your radian measure of your angle. So let's think about it like this. The definition for circumference from geometry is 2 times pi times the radius. Well, in this picture, if we consider the radius to be 1, then that would make the circumference 2 times pi times 1, or 2 pi radians. And if we think about going all the way around our circle on that boundary, that would be a measure or a length of 2 pi. If we only go halfway around, that would be 1 pi. Up at the top, if we cut 1 pi in half, that would be pi over 2 radians. So 1/4 of the way around the circle would be pi over 2. And at the bottom of the circle, if we go 3/4 of the way around, that's actually 3 pi over 2 in radian measure. Now there's an easy way to convert from one form to the other. If you're given an angle in degrees and you want to convert it to radians, what you do is you take the degree measure theta and you multiply it by pi and then divide that answer by 180. It's that simple. To go back from a radian measure, a length value, to degrees, you would take your theta in radians times 180, and then you would divide by pi. You're multiplying it by the reciprocal fraction. Let's put a couple of these to the test. It says in the first part, convert from degrees to radians. Notice for A and B, we have degree symbols with each of those angle measures. This means theta equals 20 degrees. To convert to radians, that's an equal sign. To convert to radians, what you'll do is you'll take 20 degrees, multiply it by pi, and then divide by 180. Reducing that fraction, I can divide the top and bottom by 10, giving us 2 pi over 18. Well, 2 goes into 18 9 times. That means this would be a measure of pi over 9 radians. That's not a very big distance on the circle to travel. Now, negative 250, it works for negative measures as well. In this case, we'll just let theta equal negative 250. And if we want to convert that degree measure to a radian measure, we'll take negative 250 times pi divided by 180. And then simplify. We can divide top and bottom by 10 again, and now we end up with negative 25 pi over 18. That doesn't reduce any further, therefore this will equal negative 25 pi, whoops, I got ahead of myself there, negative 25 pi over 18 radians. Call it rad for short. To go in the reverse order, from radians to degrees, now notice each of our answers either has a pi symbol or it's missing a degree symbol. 3 pi over 4 would be 3/4 of a full unit of pi on that circle. So notice that would be somewhere in quadrant 2. To verify that, we'll take our theta value, which in this case is 3 pi over 4 radians, and we'll multiply that by 180 and divide by pi. In this fraction, notice the top pi and the bottom pi cancel. 3 times 180 is 540. divided by 4, which would be a total of 135. Now your label for this, if we're going 2 degrees, is a degree symbol. And 135 degrees would in fact be in quadrant 2. Now that next example is negative, but it's also an approximate. Notice it's negative 3.14159. You may be able to tell where I'm going with this one. If that's what your radian measure theta is, what we'll have to do is plug this whole thing in our calculator. To convert back to degrees, we'll take negative 3.14159 times 180 divided by pi. So if you do your order of operations, negative 3.14159 times 180 divided by pi, you should get negative 180 degrees. And that's halfway around the circle. Just like degrees, radians can have coterminal measures. Given a radian, we'll call it alpha, like we did yesterday in degrees. To convert or find coterminal radian measures, instead of adding and subtracting 360, we'll add the radian conversion of that, which is 2 pi, and I'll put it over 1. And the reason why I'll do that is we'll need to get a common denominator when we add or subtract. And then those radian measures will end at the same terminal ray. To find complementary and supplementary radian measures, again you want 2 positive measures. For complementary, instead of adding up to 90 degrees, they have to add up to pi over 2, which is the equivalent to 90 degrees. Supplementary, instead of 180, the radian version of that would be 1 pi. We'll get lots of common denominators when we do coterminal, complementary, and supplementary radian measures. This is where our lesson becomes somewhat tricky. It says for each radian measure, sketch the angle. So we're going to figure out where on the circle the intercepted arc would match up for that radian. For B, determine 1 positive and 1 negative coterminal angle. C, find its complement and supplement. As we think about where these locations will be within each of the 4 quadrants, we think about things like 0, pi over 2, 1 pi, 3 pi over 2, and 2 pi. Those boundaries that we kind of wrote at the top. Pi over 5 would be the same as 1/5 pi. Now 1/5 pi is going to be greater than 0, but it's less than 1/2 pi. 1/5 would be smaller than 1/2. So we know that that would be true. That means our radian measure is going to be somewhere on our circle in quadrant 1. So I'm just going to draw a real basic sketch here. I know that my radian measure would start at 0 on the side, but it's going to rotate up on that circle in a counterclockwise direction. Now 1/5 is quite a bit smaller than 1/2. That means we're only going to go up on that circle a small distance. That length would be pi over 5 radians, and it's just an approximation. For part B, determine 1 positive and 1 negative coterminal angle. Now coterminal angles would be the same initial and terminal sides, or in this case the same initial and terminal point on the circle, but just going one full time around. What we'll do here is we'll take our initial angle and we're going to add and subtract 2 pi over 1. That would be 1 full revolution in either direction. In order to add and subtract fractions, we need a common denominator. A common denominator of 5 and 1 would be 5. That gives us pi over 5 plus or minus, well 2 pi over 1 would be equivalent to 10 pi over 5. Therefore, to get our positive angle measure, if we add them, pi over 5 plus 10 pi over 5 would simply be 11 pi over 5. And if we subtract them, sorry about that, pi over 5 minus 10 pi over 5 would be negative 9 pi over 5. There's one positive and one negative coterminal angle. Last but not least, to find the complement and the supplement. Complements, two angles that add up to pi over 2, or in degree form 90 degrees. To figure out the complement, we would take pi over 2 and subtract our initial angle. In this case, we'll need to change both the denominators. 2 and 5 will both go into 10 evenly. Pi over 2 is the same as 5 pi over 10. Pi over 5 would be the same as 2 pi over 10. And that gives you a difference of 3 pi over 10. 3 pi over 10 is the complement, should have written that first, sorry, 2 pi over 5. The supplement is the same idea, but now these are the angles that get you halfway around that circle, and they would have a sum of 1 pi. If we take 1 pi minus pi over 5, technically 1 pi is pi over 1. Our common denominator here would be 5. 5 pi over 5 minus 1 pi over 5, and that's just 4 pi over 5. Whoops. We'll get the pi symbol in there first. 4 pi over 5. That is the supplement. Just finding two angles that would either add up to pi over 2 or 1 pi. In that next example, negative 4 pi over 7. We have to use our best strategies here with these fractions. Don't worry so much about the negative. Let's just think about 4 pi over 7. We'll get the direction later. 4 pi over 7. We know that that's greater than 0. It's also going to be greater than 1/2. 4 over 7 is just bigger than 1/2. So I'm going to get rid of that 0. Whoops, I just kind of shaded it in. That was random. There we go. I'm going to get rid of that 0, and I know it's even bigger than pi over 2. My next boundary would be 1 pi. 4/7 is definitely less than 1. So that means I'm going to be just over 1/4 the way around the entire unit circle. I hope that was easy to follow. What makes it even crazier is because of that negative, we have to go in a clockwise direction. We'll start on the circle. If we go to pi over 2 in a clockwise direction, that puts us at the bottom. But then we have to keep going a little bit further because 4 pi over 7 is beyond that, in that negative direction. That's the portion of the circle that we're looking at. All right, after that, let's take a look at coterminal angles. Take negative 4 pi over 7, and we'll add and subtract 2 pi over 1. I'm getting ahead of myself here and missing some parts. Sorry. 2 pi over 1. A common denominator of 1 and 7, this is going to be pretty common in this process, would be 7, and that makes 2 pi over 1, 14 pi over 7. To get the positive coterminal angle, if we take negative 4 pi over 7 plus 14 pi over 7, we just get 10 pi over 7. That would be coterminal with the original radian measure. If we take negative 4 pi over 7 minus 14 pi over 7, that crazy radian is going to be negative 18 pi over 7. That would be your negative coterminal angle. And last but not least, your complement and supplement. We'll take a look at this. If theta equals negative 4 pi over 7, it's a negative radian measure. And by definition, complements and supplements have to be two positive measures. So that means this one has no complement or supplement because it's a negative angle. Radian measure. Sorry, it's a negative radian measure. All right, I think that's enough, you guys. We will finish this last example and the next page in class tomorrow.